Hello, good afternoon. This is Saraj Jain from Electronics Communication Department. Today we'll discuss about the diode. Diode is a two-terminal active device. It's a non-linear device having non-linear characteristics. The symbol of the diode is like that one. It has two leads. The name of the two leads are anode and cathode. However, there is a arrow. This arrow indicates the direction of flowing current in the diode. One bar is there. This bar indicates the cathode. Diode is used in number of applications today in electronics industry. Diode is used as a limiter. It is used as a logic gates. In clipper we use the diode. In radio circuits we use diode in mixer. We use the diode as a clamper in television circuits. Diode is used to remove a portion of a signal in a clipper circuit. It is used for phase detection also. In gain control circuit we also use diode. It is used in power detector. It is used in AGC circuits. It is used in limiter and phase detector also. So number of applications are there of diodes. First we start the basic structure of the diode. Actually diode is a PN junction diode. So diode is made from two type of semiconductors material. There is P-type semiconductor material and N-type semiconductor material. So when a P-type semiconductor material is suitably joined to the N-type semiconductors, a junction is made between the two types of semiconductor. This is called the PN junctions. However, in the P-type semiconductor material, the majority charge carriers are holes and the minority charge carriers are electrons. However, in the negative N-type semiconductor material, the majority charge carriers are electrons and the minority carriers are holes. So both type of charge carriers are present in P-type semiconductor and N-type semiconductor. Okay. So we can say this arrow indicates the direction of flowing current through the diode. So we can say the current flows through the diode in only one direction, from that is anode, from anode to cathode. However, in a certain condition, and that condition is when anode is made positive with respect to cathode, this condition is called forward bias. In other words, we can say whenever a diode's anode is made positive with respect to its cathode, it becomes to be forward bias. So current starts to flow through the diode in the direction from anode to cathode. However, another condition where diode's anode is connected to negative voltage and cathode is connected to positive voltage, means cathode is at higher potential than the anode. In such conditions, no current will flow through the diode, and this is called the reverse biased condition of the diodes. So in the forward bias current flow, diode allows to flow the current through him and it acts like a short circuit. However, some voltage drop is there of the order of 0.7 volt for silicon and 0.3 volt for germanium. And in the reverse bias, when we connect the anode of the diode to negative and cathode of the diode to positive, no current will flow. The diode will act as an open circuit. This is called the reverse bias condition. However, the resistance in the forward condition of the diode is very less, so it offers the flow of current, while the resistance of a diode in the reverse bias condition is much more, so we can say practically no current flow. However, this is the VI characteristics of the diode. This is the first quadrant. In the forward bias condition, when we start to increase the voltage, initially the diode will not conduct because a potential barrier is there inside the diode. When we increase the input voltage smoothly, say 0.7 volt for silicon and 0.3 volt for germanium, after crossing this potential barrier, the diode start to conduct and sharp current flows through the diode. So this is shown by this curve. This is of parabolic picture. So this is a forward voltage drop. This is 0.7 volt for silicon, 0.3 volt. This is the forward characteristics. After eliminating the barrier potential, the current will start to increase through the diode, and it will increase as soon as we increase the voltage. However, in the reverse bias condition, if we start to increase the voltage in the reverse direction, no current will flow because the diode is reverse biased. However, some current flows due to the minority carrier that are thermally generated minority charge carriers, but this current is of the order of nanoamperes. So practically it is not useful. However, when we start to increase the reverse voltage in the reverse direction, a condition is reached when we increase the voltage up to the breakdown voltage. A breakdown occur of the diode and heavy current will start to flow through the diode. This is called the breakdown mechanism of the diode. However, there are two types of breakdown mechanism, that is the avalanche breakdown and the Zener breakdown. Actually, we should avoid this condition because when we increase the reverse voltage in the reverse direction, it may be dangerous to diode because a heavy current will flow through the diode, and this current, if not controlled through some external resistant, it may damage the diode because it will increase the temperature of the diode beyond the limit the diode can tolerate. So we should avoid always this condition. However, in the case of Zener, the Zener diode always works in the reverse biased, but it is safe condition. So we can say the diode works in the forward bias and it does not conduct in the reverse bias. However, mostly we use the diode in the forward bias condition, not in the reverse bias condition.